Last thing I want to talk about in terms of graphing sine and cosine is that we'll have shifted sine and cosine curves, okay? Suppose we have y equals a sine of k times x minus b. You can think of that as all kind of in the argument. And ay equals a cosine of k times x minus b. Well, they have amplitude, the absolute value of a, and they have period 2 pi over k, same story. However, they have a phase shift b. Now, what a phase shift b means is that we take the whole period of your sine or your cosine and we shift that whole period b units. So if it's x minus b where b is positive, we shift it to the right. If it's x minus b where b is negative, we shift it to the left, b units. Let's take a look over here. So suppose I have y equals 2 sine of 4 times x minus pi over 2. First thing that we want to identify was the amplitude. So the amplitude in this case is equal to the absolute value of a, which in this case is the absolute value of 2, which is 2. We also want to talk about the period. Well, what's the period? Well, it's 2 pi over k, which in this case is 2 pi over 4, which is pi over 2. So we have a pi over 2 period. It's a condensed period. Rather than 2 pi, it's in pi over 2. The last thing we want to know is what the phase shift is. Okay, and the phase shift in this case is pi over 2 units to the right. It always has to be of the form x minus b. So if it's minus pi over 2, we're going to shift it to the right pi over 2. Suppose it was minus negative pi over 2, we shift it to the left pi over 2. Now, of course, if it's minus negative pi over 2, it's actually plus pi over 2. So if it's a plus in here, we're going to shift it to the right. And if it's a minus in here, or excuse me, if it's a plus in here, we're going to shift it to the left. If it's a minus in here, we're going to shift it to the right. That's the easy way to remember it. Okay, let's take a look. So the phase shift is pi over 2. Now, I'm going to show you the way I graph it. It's actually rather simple. I like to just do everything but the phase shift. I like to graph everything and then just shift it, in this case pi over 2 units, to the right. So let's take a look. I'm just going to graph, I'm not graphing this whole function. Right now I'm going to do a separate problem. I'm going to do y equals 2 sine of 4x. That's what I'm going to graph. I'm going to graph that, and then I'm going to shift it to the right pi over 2. So if I have a height of, an amplitude of 2, so I'm going to have a 2 up here, and I'm going to have a negative 2 down there. I know that my whole period is done in pi over 2. So the whole graph of sine is going to be done from 0 to pi over 2. I got a halfway mark right here, pi over 4. Halfway there is pi over 8. This is going to be 3 pi over 8. So I'm going to have my whole sine function in pi over 2. That has a height of 2 and a low point of negative 2. So let's go ahead and graph that guy. And I think it's going to look something like this. So we go here, here, here. Simple enough, right? Well, what does this pi over 2 phase shift do to it? So this green one is not the blue one. I'm going to graph the blue one now by simply taking this and shifting it, because it's minus pi over 2. I'm going to shift this whole thing to the right pi over 2 units. So I'm going to take this point, put it here, this point, put it right here, this point, put it here. I'm shifting this whole thing pi over 2 to the right. So let's go ahead and do that. So now I'm going to start here at pi over 2 and have my whole period. My period is still pi over 2, so this will put this at pi. And I'm going to graph the whole thing still, again, 3 pi over 4, okay? I'm going to graph this whole thing the same function, but now it's the blue one, okay? But I'm going to graph this whole thing the same thing, just shift it over to the right, pi over 2. So 1, 2, 1, negative 2. So we're going to go here, here, and here. It's the same thing, shifted over, pi over 2. Okay, let's try another one. I got y equals negative 3 cosine of 2 times x plus pi over 4. Again, I don't like graphing it with the phase shift first. My technique is to just simply graph it without the phase shift and then shift it over. In this case, if we graph this guy and then shift it to the left pi over 4 units, we'll have it. So let's graph this guy first, figure out what that is, and then shift it to the left pi over 4 units. Awesome. Okay, so I know that my amplitude here for this blue one is going to be 3. So the amplitude is going to be the absolute value of negative 3, which is 3. I know that negative makes it start downwards if it's sine, or start at that low point if it's cosine and work up. So I know that negative, what that does is it flips it with respect to the x-axis. Okay. I also have the period. Okay, the period in this case is 2 pi over 2, which is just pi. So the whole thing's going to be done in a span of a period of pi. Well, I'll put pi right here. Fantastic. That puts pi over 2 right here. That puts pi over 4 right here. And 3/4 pi right here. We can graph this blue function. Again, this is not this black function. This is this blue function. It's completely different. But I'm going to graph it. Again, I start down here, and the reason for that is because it's negative. So I'm going to go through this process. Okay, I'm going to hit here. I'm going to cruise up, get to my point, come back down, hit here. This is the graph of y equals negative 3 cosine of 2x. That's not the answer. The answer is taking this function and shifting it, in this case, to the left, because it's plus, to the left pi over 4 units. So I want you to imagine taking this thing and just shifting it over pi over 4 units. So my answer is actually going to be in green. So my answer to this is taking each of these points and shifting it over to the left pi over 4 units. So if I take this point, shift it over pi over 4, take this point, pi over 4, this point, pi over 4, that point, pi over 4, and that point to negative pi over 4 right here, that gives me my green function here, negative 3 cosine of 2 times x plus pi over 4. And I think this technique helps because a lot of students get lost in the details here of this pi over 4 shift. And so what I like to do is I like to graph it without it and then move it over. Now I do want to note one thing, is that you can make these tougher, as an instructor, you can make these tougher by making it dressed up a little bit, if you will. So suppose I had written this as negative 3 cosine, but suppose I had distributed this and I gotten 2x plus pi over 2. Now that looks like, oh, I've got an amplitude of absolute value of negative 3, and my phase shift is pi over 2, and my period is 2 pi over 2, but that's not correct. It always has to be in this form. That is to say, we always need to factor it out so that we have this k value on the outside of my phase shift. And that's very important.